Imagine a time when the universe was just 500 million years old, utterly dark, silent, and mostly empty. No stars like our sun, no galaxies spinning gracefully through space. And yet, hidden deep within that ancient darkness, something massive was already there. NASA's James Webb Space Telescope recently uncovered a cosmic enigma, supermassive black holes that existed long before they were ever expected to. How could something so colossal, millions of times the mass of our sun, form in such a short span of time? What does this mean for our understanding of the universe's beginning? For decades, scientists believed that black holes formed from dying stars, slowly growing larger over billions of years. But what if that's not the whole story? This is not just a discovery. It's a challenge to everything we thought we knew about the universe. To understand the ancient black holes, we must first meet the instrument that found them, the James Webb Space Telescope, NASA's most ambitious observatory to date. Launched in 2021, JWST is designed not just to see stars, but to look back in time, literally. Because light takes time to travel, the farther we look, the older the universe appears. Webb's powerful infrared eyes allow it to pierce through dust and distance, revealing galaxies as they were billions of years ago. Unlike the Hubble Space Telescope, which sees mostly visible and ultraviolet light, Webb was built specifically to detect infrared light, the faint glow from the very first stars and galaxies. And it worked. Webb has already shattered expectations, finding galaxies and black holes so ancient they appear to exist before they even should. But how does it find something that emits no light at all, like a black hole? That's where things get even more fascinating. James Webb doesn't see black holes directly. It detects their gravitational influence, the energy they release as they consume matter, and the way they warp the light around them. One of James Webb's most shocking discoveries came from a tiny red dot in deep space. What looked like a faint distant galaxy turned out to be home to a black hole 38 million times the mass of our sun, and it existed only 500 million years after the Big Bang. This object, known as Kuiper's LRDZ9, belongs to a strange group of galaxies called little red dots. They are small, dim, and incredibly ancient, but some hide supermassive black holes at their cores. Another discovery, UHZ1, showed a similar story, a galaxy existing just 470 million years after the Big Bang, hosting a central black hole possibly 40 million solar masses or more. These aren't isolated cases. Webb has found multiple early galaxies with disproportionately large black holes, far more massive than we'd expect based on the number of stars around them. Normally, in galaxies today, the black hole's mass is about 0.1% of the galaxy's stellar mass. But in these ancient galaxies, black holes make up 5%, 10%, even more, a staggering imbalance. It's as if the black holes were growing faster than their galaxies. Or worse, maybe they came first. These discoveries forced scientists to reconsider what they thought they knew about cosmic structure. Because if the biggest objects in the early universe were black holes, then perhaps galaxies were just their byproducts. For decades, scientists believed black holes formed from the deaths of massive stars. A star would collapse into a small black hole, and over billions of years, it could grow by swallowing gas, dust, and sometimes merging with other black holes. This growth process is slow. Even under the best conditions, it takes hundreds of millions, if not billions, of years to form a supermassive black hole. But now, with James Webb, we're seeing these giant black holes already fully formed just 400 to 500 million years after the Big Bang. That's far too early. To match the mass we're observing, a black hole would need to grow at the theoretical maximum speed allowed by physics, called the Eddington limit. non-stop for hundreds of millions of years. And even then, it's a stretch. These black holes are just too big, too early. That raises troubling questions. Are our models of early star and galaxy formation wrong? Could black holes form through a completely different process? What if these massive black holes didn't grow, but were born big? Webb's discoveries are not just surprising, they're disruptive. They challenge the timeline of cosmic evolution, and they force us to rethink the very beginning of structure in the universe. What if black holes weren't the result of galaxies, but the reason galaxies exist at all? If supermassive black holes didn't have enough time to grow slowly, then how did they get so big so early? Scientists have proposed several possible explanations. Each is fascinating and controversial. Theory 1. Light seeds plus supercharged growth. In this model, black holes begin as the remnants of the first massive stars, called population 3 stars. These stars explode, leaving behind black holes a few tens of solar masses. If these light seeds start feeding on gas immediately and grow at the Eddington limit or even beyond, it's just barely possible for them to reach millions of solar masses in a few 100 million years. But this requires perfect conditions: dense gas, low feedback, and uninterrupted feeding. One disruption, and growth stops. Theory 2. Heavy seeds / direct collapse. This model skips the star phase. Instead, entire clouds of primordial gas, 10,000 to 100,000 solar masses, collapse directly into black holes. These heavy seeds are born big, removing the need for long-term growth. But such a collapse requires very special conditions: intense radiation to prevent stars from forming, low metallicity, and just the right environment. So while it solves the timing problem, it raises others. Theory 3. Primordial black holes. The most radical idea. What if some black holes were born before stars, even before galaxies? In the first fractions of a second after the Big Bang, extreme density fluctuations might have created black holes directly. These primordial black holes could survive to this day, and might even be part of the mysterious dark matter. But evidence for them is sparse, and the theory is still speculative. No theory fits all the data, and that's what makes this discovery so exciting. We're at the edge of what we understand, and just beyond that edge might lie a completely new story about how the universe began. For years, scientists assumed a natural order: first stars, then galaxies, and finally black holes forming at their centers. But the James Webb Space Telescope may be telling us a different story. One of its strangest discoveries is an object known as QSO-1, a supermassive black hole found in the early universe, with almost no galaxy around it. A black hole, seemingly naked. It's like finding the heart before the body. This challenges everything we thought we knew about cosmic formation. Could black holes be the seeds from which galaxies grow, not the other way around? In modern galaxies, black holes and their host galaxies are tightly linked. The larger the galaxy, the more massive its central black hole, suggesting they evolve together. But QSO-1 suggests something else. Perhaps some black holes formed first, attracting gas and matter around them, eventually building up the galaxies we see today. If true, this flips the timeline of cosmic structure upside down. Black holes weren't just born within galaxies. They might have been the architects of galaxies themselves. And that idea is as beautiful as it is unsettling. The James Webb Space Telescope has only begun its mission, and already it's rewriting our understanding of the early universe. Black holes that shouldn't exist, galaxies that formed too fast. Each discovery opens a new question, deeper than the last. Are we witnessing the first clues to a cosmic story we've never imagined? Or simply uncovering what has always been hidden? waiting for us to see. One thing is clear: the universe is more mysterious, more beautiful, and more alive than we ever thought. And as we look further back in time, we may not just learn where we came from, but why we're here at all. If you enjoyed this journey into the depths of space, don't forget to subscribe, like, and share with others who love the universe as much as you do. Let's keep exploring together.